In our last video on complex numbers, we're going to look at complex number division. Specifically, we're going to be dividing things like this. 2 plus I divided by 4 plus 5i. We're going to write our answer as a complex number in the form a plus bi. Now, the problem that we have with this is that I is an imaginary number, which we already know, but if we define I as the square root of -1, typically we do not leave a denominator with a radical in the bottom. What we're going to need to do then is try and get that out of there. So what I'm going to do is rewrite this down here just so I have a little bit of room. My process is going to be to get rid of that denominator by doing something called multiplying by the conjugate. So we already looked at conjugates in the last video, where if I took this denominator 4 plus 5i, the conjugate of that is 4 minus 5i. What I'm going to do then is multiply the top and the bottom, so the numerator and denominator, by that 4 minus 5i, which again is the conjugate. So in the top, I've got a couple options on what I can do. If I need to do the area model, then I'll do it. If I can do it with distribution, then I'll do it. So I'm going to take 2 times 4, which gives me 8. 2 times -5 is -10i. I times 4 is going to give me 4i. And I times -5i is -5i squared. In the denominator, because I'm dealing with the conjugate, I don't need to do the full multiplication. I can multiply the first numbers 4 and 4 is 16, and the last numbers 5i times -5i is -25i squared. So that's my original step, the original multiplication. The next thing I want to do is combine some like terms and see if I can simplify. So I know the i's together, -10 plus 4 is going to give me -6i. I have an 8 here and a -5i squared. So a -5i squared is going to turn into a +5, and the 8 gives me a 13. Divided by 16, and then minus 25i squared would be 16 plus 25, and so that's 41. So, I mean, in the grand scheme of things, in theory, I could leave my answer like that, but my directions are saying write it in the form a plus bi, which means I do actually want to separate those fractions out. So I'm going to rewrite this as 13 over 41 minus 6i over 41. And that's my answer because, again, there's no reduction I can do at that point. Another example of this type. So here we have a problem where it's very similar. 6 plus I divided by 4 minus 3i. Again, first thing I want to do is identify what my conjugate is. And so the conjugate of 4 minus 3i would be 4 plus 3i. So I'm going to take and do the multiplication here. So I'm going to multiply the top, if it'll let me. Grab a pen. I guess it doesn't like that color. Multiply top and bottom by 4 plus 3i. So again, multiplying the numerator, 6 times 4 would give me 24. 6 times 3i was 18i. I times 4 is 4i. And I times 3i would be 3i squared. In the denominator, I'm just going to multiply again the first part, so 4 and 4 is 16. Negative 3i times times positive 3i is negative 3i squared. And so next I want to combine my like terms. So 24 and 3i squared will combine. 24 and then -3 basically gives me 21 plus 22i, all divided by 16. Whoa, I totally messed it up. Sorry about that. Whoa. Here we go. That should be 9i squared. 3 times 3 apparently is not 3. Anyway, so we have 16 and then minus 9i squared becomes plus 9, so then becomes a 25. So my reduced fraction becomes 21 over 25 plus 22i over 25. And so that's my final answer. Now, sometimes division is going to be a little bit easier to do. We can just take our expression and divide through by the number in the denominator. In this case, because we have no I in the denominator. So essentially, we're just trying to simplify that fraction a little bit easier. And it's not a binomial, so there is no conjugate here. So if I just divide these out, I'm going to have 9 over 3 plus 12I over 3, which gives me 3 plus 4I. So sometimes it's a little bit easier to do than the whole long process. Works the same if we have an imaginary number on the bottom that's not a binomial. We can follow that same process we did up here and separate it out. 7 over 2I, and then this would become 5I over 2I. So this will simplify down. I'll make that 5/2 when I can. But this one I still need to do a little bit of work because that I is in the denominator. So what I'm going to do is I'm going to multiply the top and bottom by I so that they will cancel out. So essentially in the bottom, I'm going to have an I squared. So this gives me 7I over 2I squared. And I know that when I have that I squared in the denominator, that's going to become a -1. So my denominator really becomes -2. So the whole thing is going to become -7 over 2 times I. Now I want to write it in the form a plus bi first though, so I want to take care of this real number component, which is 5/2. But then this term will become negative because of that I squared. I'll have 7 over 2 and then times I. So the last thing we're going to do today is we're going to look at taking some expressions and being able to put them together. We'll look first at an addition problem, and then we'll look at a more complicated division problem. So these are two fractions that I want to put together. But in order to do that, I have to have a common denominator. So looking at my denominator here, I've got I minus 2I and I plus 2I. There's a lot of commonalities there, but they don't have the same denominator. And I can't just change the sign of 1 to make it work. It doesn't work that way. But what I'm going to end up having to do is to include this I plus 2I over here somehow, and this I minus 2I over there somehow. Now remember that if I want to take a fraction and keep it the same, I'm going to multiply top and bottom by the same number. That's just effectively multiplying by 1. That's not going to change a number at all. So I can take that 1 plus 2I and multiply it in the top and bottom of that first fraction. Similarly, I can take 1 minus 2I and multiply by both of those components. So at this point, I want to distribute. So in the numerator, I'm going to have 3 plus 6I. And in the second one, I'm going to have 4 and then negative 8I. In the denominator, these are both the same denominators. So I can just multiply that through and find out what it's going to be. So 1 times 1 is going to give me 1. Negative 2I times positive 2I is negative 4I squared. So now what I've done is taken those and put them as one fraction because they have the same denominator. And so now it's just a matter of simplification. So looking for like terms, I have a 3 and a 4, which gives me 7. I've got a 6i and a negative 8i, that's a negative 2i. And I'm going to divide that by 1 minus 4i squared, which is really 1 plus 4, so that becomes 5. I'm not quite done though, because I need to separate those guys out. 7/5, and then minus 2i over 5. All right, and the last one gets a little complicated here. So what I've got going on here is 2 plus I divided by 3 minus I, and I'm dividing by this other fraction. So when we are dealing with fractions, we generally don't actually divide fractions, we multiply by reciprocals. So I really want to treat this like 2 plus I over 3 minus I times 1 plus 4I over 1 minus 2I. And I'm going to multiply the numerators together, and I'm going to multiply the denominators together. So I'm going to have 2 plus 8I, so that's distributing the 2 to both those terms. In the denominator, I'm going to have I times both of those, so I plus 4I squared. In the denominator, 3 times 1 is 3. 3 times negative 2 is negative 6I. Negative I times 1 is negative I. and negative I times negative 2I would be 2I squared. So I'm going to look to put these together in my next step. Again, the I squareds become negative 1s, so this becomes 2 and then minus 4, that's negative 2. The i's together give me 9I. In the denominator, I'm going to have 3 and then a negative 2, that's 1, and then minus 7I. So I've done some things that put those two fractions together. However, I still have that imaginary number in the denominator. So we're going to do like we did before, where once we're at that step, we're going to take our conjugate of the denominator and multiply the top and bottom by that conjugate. So taking the negative 2 and distributing it, I'm going to get negative 2 minus 14I. Taking the 9I and distributing, I'm going to have 9I plus 63I squared. In the denominator, I'll have 1, and this becomes negative 49I squared. And I can skip those middle terms because I know they're going to cancel because I'm multiplying by the conjugate. So I'm almost there. Step or two away. Combine like terms, so I've got a negative 2, and this will become a negative 63, so that's negative 65. And then negative 14I plus 9I is negative 5I. In the denominator, that will become 1 plus 49. I can rewrite that. I'm just going to call it 50. I don't think I need to show that step. So almost there. Our next step is to take those 50s and put them underneath each piece. I just have one more thing to do, which is to simplify my fraction. So 65 and 50, I can take a 5 out of those. That's going to give me negative 13 over 10. And the same thing here, I can take a 5 out of both of those, so negative I over 10 as well. And that is my final. So we looked at a lot of different things, how to divide by multiplying by the conjugate, how to simplify a radical, or not a radical, something with an imaginary number in the denominator, and then combining fractions with either addition or subtraction, and then dividing fractions within fractions.